All right. I should know this. Take the next minute and answer as many as 1 through 6 as you can on your own. What do you know about transformations? Go ahead and answer them. They're right on your paper. Yep, 1 through 6. Go ahead. All right, so transformation that slides them an image. You guys should have your notebooks out, and you should be looking back in your notes to try and answer this question. What is a transformation that slides an image? Who can tell me that answer? So? Where's your notebook? Jasmine? Translation. Thank you. Good job, Jasmine. It is a translation. If your notebooks are not out, they should be getting out now, because that has all these definitions that I asked you to write down, or it should anyway. So a dilation is a transformation that blank or reduces the size of an image. We just did those the past 2 days, Friday and today. What does a dilation do? Blank or reduce? Anybody? All right, so number 2, a dilation that is transformed that blank or reduces the size of an image. Angel? Angel, thank you for raising your hand and waiting for me to call on you. Angel? What? Number 2. Origin? Struggling with that one. Christian? Enlarges. Okay, number 3, this transformation turns an image about a point. It's the transformation, not where it's being turned around from. So what kind of transformation, Kevin? Well, that gives me a direction, not the name of the transformation. What kind of transformation is going to turn about an origin, Christian? Not a reflection. You're close, though. It is a transformation. What kind of transformation turns? Noah? Rotation. So we're talking about, thank you, Noah, rotations. True or false? A transformation produces an image that is always congruent. That is true. Oh, wait. Sorry, I lied. That is false. Why is it false, though? But why is it not true? Why is it not true? So a rotation is going to be identical, right? It's not going to change its shape or size. Listen. A translation is just going to slide it. It's not going to change its shape or size. A reflection is just flipping the image. It's not going to change its shape or size. What about a dilation? What does a dilation do?
It goes down.
It goes down, so it reduces, or it
goes up.
Makes it bigger, enlarges. Let's use the words, the vocabulary that we have provided for you. Okay, so I want to use reduce and enlarge. Okay, so does that keep its shape then? Keeps its shape. Does it keep its size? So, but it doesn't keep its size, does it? It changes its size. Therefore, it does not remain congruent. Congruent means the same. It is similar in shape and size, but is not the same. Understand? That's why it's false. So the blank is a number that multiplies an image, which results in a dilation. Who has that answer? What do we multiply by? So?
We multiply by the numbers that...
What do we call that number?
We call those fractions.
Emmanuel? Scale factor. It is a scale factor. It's not always a fraction. Sometimes it's a whole number. That makes it larger. Fraction reduces it. This transformation mirrors an image across a line. What's that one? It's our last transformation. I would thank you for raising your hand and waiting for me to call on you. Christian? It is a reflection. All right? Does everybody have these written down? All right, let's look at number 7. So it wants us to graph these 4 points. So -4, -3, 1, 2, 3, 4, 1, 2, 3. This would be my R. D is going to be -4, 0. L is 0, 0. That would be my point of origin. So you guys should have graphed this already. F is 0, -3. And you should be using your straight edge to connect those points. So the translation is asking us to move it 3 units up. So we're going to go up 3. 1, 2, 3. D becomes R prime. 1, 2, 3. This is D prime. L becomes F prime. And that, move it up 3. So now we have a translation, which just means slide up 3 units. So this one you actually had to graph. There you go. Lighting's better. This one you had to graph and then slide. Okay. The rest of them are already graphed for you. You just have to do the translation. So I'm going to give you 10 more minutes, and you guys should do 8 through 12. 10 minutes. Be quick. We're going to look at our translation.
I'm done.
I know. We're looking at number 8. Okay? Translation. So this means we're just going to do the slide, right? So 1 unit right, 2 units down. So each point, you take 1 unit right, 2 units down. This becomes my new prime point. 1 unit right, 2 units down. That's all we're doing. We're just sliding this image. 1 unit right, 2 units down. We take our straight edge and connect these points. And now we have a translated image, which means we slid this whole image 1 unit right, 2 units down. Did everybody get that one right?
Yeah.
Good. The translations are easy. I'm going to skip now. I'm going to skip to reflection. I'm going to do number 13 with you. Then I'm going to give you some time to do 14 and 15. So this tells me, actually, let's do a difficult one. Let's do 15. Y equals -x. Now, if you remember, best way to do this is your y is going to be a -x. 0 doesn't have a positive or a negative. My y is going to be a -x. Okay, so if I graph this, I went from my point of origin, -1, 1, 0, 0, -2, +2. That gives me a downward on the diagonal reflection line. Okay, so this here is my line of reflection. So since it's diagonal, I'm going to count diagonal to that line of reflection for each point. So from J, that is a J, isn't it? J to my reflection line, it's only half of a diagonal box. That means I'm going to go half again and label it J prime. For T, I'm going to count 1 1/2. So half, then 1. And that gives me T prime. A, I'm going to count 1 to my diagonal, and then again diagonal A prime 1. S, that's going to be a bigger one. 1, 2, 3 on the diagonal to my line of reflection. 1, 2, 3 is going to give me my S prime. Got it? So there's my reflection. So here's the kicker. This is some really good practice for you on your homework tonight. I want you to do a cross off 1 through 8. Cross off 1 through 8. Huh? On your homework tonight, cross off 1, 2, 3, 4, 5, 6, 7, and 8. So you're going to start with number 9. And you're going to go all the way to number 18.
Wait, which ones do you cross out?
Cross off 19 and 20. So you're only responsible for tonight's homework numbers 9 through 18. That's all I'm going to expect you to do tonight. Because your quiz, excuse me, as I was saying before I was interrupted, your quiz tomorrow is only going to be on dilations and rotations. Okay, we haven't done composites yet. That's 19 and 20. We're going to do those tomorrow or the day after. Okay, so you're only responsible for your homework tonight, number 9 through 18. That's all you have to do on your homework. All right, so I showed you an example of a translation and a reflection because one of them you might have to do multiple moves. Let's go ahead and flip your paper over. And work on the rules. So let's look at 19. So, to find the rule, okay, because you may have a question that's asking you to find the rule, you have to find the midpoint or figure out how you got from A to A prime. Okay? So it could be one of two ways, right? Either a rotation, this one, or a reflection. So here's my A, here's my A prime. If I'm reflecting, it looks like my midpoint's going to be X. That might work, right? But what about a rotation? Let's say I did a rotation. Now my A is in quadrant 2, so it's not a rotation, right? If you look at your A, where does your A prime? What quadrant? 1, right? So if I tried a rotation to get my A prime up on the top, where'd I go? My A is now in quadrant 2, so it's not a rotation. It has to be a reflection across this axis. How do I know it's across the X? Because that would be in the middle, right in between. So if I count it from G to G prime, 1, 2, 3, 4, 5, 6, 7, 8. Half of 8 is 4, so let's count down 4. 1, 2, 3, 4. That gives me this point here. Midpoint for my R's is here. 1, 2, 3, 4. Count up 2. That's half of 4. There's my midline. So if you notice, it's right on the x-axis. Okay, so that is my reflection. So my rule would be reflection across x-axis. It's not always going to be a reflection though. What else could it be? What's our other transformations that we've done? Rotation or translation. So you have to figure out, it's going to be one of those three. It's not a dilation. They didn't change because if you look at them, they didn't change size, right? They're the same size, same shape. If they had changed size, then you would consider dilation. But it's not. And that won't be one of the rules that we ask you. Okay? So go ahead and keep working on this. You're only responsible for numbers 9 through 18 on the take-home. We're only going to quiz you on dilations and rotations. But you have to still know how to do translations and reflections because there may be a problem that has you do more than one thing. Any questions? All right, get to work.